Evaluate the functions for given values of x. So what is f of minus 4?
So you'd set it up like it would be minus 4 is equal to 5x minus 1. Would that be right? Or
No, not quite. Let's
okay.
let's go over this.
Okay.
If f of x is equal to x cubed,
Mm-hmm.
what's f of 2 equal to?
X of 1 or x of
No, what you do is you take whatever's in the parentheses and you plug it in for x.
2 to the third power then.
So 2
Okay.
to the third, or 8.
Mm-hmm.
Now, what would this be when there's a variable in there?
That would be is equal to x plus 1 to the third power.
Yeah. In other words, it's very simple.
Mm-hmm.
Whatever you have in the parentheses goes in place of x in the original function.
Okay.
Okay? So,
Cool.
first of all, what we have to identify here is which piecewise function are we using? Is it the 5x
Okay.
minus 1 or the x minus 9?
Um, so x is less than minus 2.
Okay.
And that'd be right. So we'd use the first equation.
Okay, now that's the function we're going to use. That's
Okay.
basically f of x, as
Okay.
long as we are less than negative 2. So
Okay.
now what is f of minus 4?
Um, it would be f or 5 times minus 4 minus 1. So it'd be minus 20 minus a minus 1.
Now hold on.
Sure.
Minus a 1, not minus a minus 1.
No. Yeah. No, just minus 1. So it'd be minus 21.
Okay, cool.
Cool.
Now what is f of minus 2? Which function do you use?
Um, you would use the second one because it is equal to minus 2.
Okay, so what's the answer? What is f of
Um,
minus 2?
so you just plug it in. So f of what is it? Minus 2 minus 9, so minus 11.
Good. About f of 0.
Um, you would use the second equation, so it'd be minus 9.
And f of 5.
You'd use the second equation, so it'd be minus 4.
Good. Let's go to number 2. What is g of 7?
Um, Aspen, stop. Are you okay? Sorry. So it would be the second equation, so it'd be minus 7 minus 1,
Give me a number.
which would be minus 8.
Okay. And notice you still struggle a little bit when you have minus a number minus another number.
Mm-hmm.
Whenever you see that combination like that, immediately make it minus 6 plus a minus 7.
Okay.
It's called turning it into an addition problem. Taking
Okay.
the fraction sign. These two are equivalent.
Yeah.
So the bottom one you would not struggle with. If I gave
No.
you that, you'd instantly know it was minus 13.
Right.
So just in your head, make sure when you see a minus number minus another number, you're just adding those two negative
Okay.
numbers.
That
Okay?
makes sense. Cool.
And what is g of minus 10?
So you'd use the first equation, so it'd be 1 half times minus 10, which is minus 5, minus 10, which is minus 15.
And g of 6?
And then g of 6 would be the second equation, so it'd be minus 7.
Look at the first equation again. We're
We're using.
using 6.
Oh, whoops. Yeah, it's the first equation.
Okay?
Yeah, my bad. And so it would be 3 minus, or minus 3 minus 10.
It's not
No, just
minus. It's not
3 minus 10, yeah. So
three.
minus 7.
Don't the
Well,
pretty much the worst mistake one can make in math is to drop negative signs, to put them there where they don't belong. You've got to keep your signs right.
Mm-hmm.
Otherwise, you're simply not going to get the answer. You
Right.
Unless you happen to get lucky and get two negative signs that turn into a positive, you know. So occasionally 2 mistakes will make a right, but not very often in math.
Okay.
You get a sign wrong, you're getting the problem wrong most of the time. What's g of 0?
So we would use the first equation. So it'd be just minus 10. Oh, stop it.
Oh, man, hold on.
No, you're good. Hey, you're good. It's alright. My dog's talking to me right now.
Yeah, I occasionally will have my dog Pie in here. You would sit up on my lap and talk to you while you're in a session if I let her.
Oh, that's awesome. Yeah, she does these like, she tells us like what she wants. Like she has a certain like voice for like her like bark for each thing she wants. Yeah.
My dog's got into shaking her head.
Really?
Well, I can't figure out whether she's just got an itch in her ear or I've started noticing a connection between her doing it and what I know she's upset at. We have 2 dogs in the house, and a second dog will start to come closer to me and possibly jealous, and so she'll sit there and shake her head.
Oh my God!
The dog doing that, and whether she knows whether it's actually shaking her head or not, I don't know. But
yeah, but,
all right,
that's weird. Yeah.
So there's 2 more parts to piecewise functions.
Okay.
That is graphing them, and then reading graphs and coming up with the function. You got to be able to do both.
Okay.
Okay. Now, what I've told most everybody, and I've probably told you because I think we've covered piecewise functions a little bit in Algebra 1, maybe not, is always start with the domain.
Okay.
Okay. So in other words, the separation line here is 1. You don't have to draw a dotted line, but I'm going to, and it's not a vertical asymptote, it's just to help you understand what we're doing. And so that's the line that separates these 2 functions. Okay, so let's start with the upper one, or the right side. In other words,
so
the first function, 2x, is going to go in this area right there.
Okay.
The next function, minus x plus 2, is going to go in that area. In other words, it's useful to think of it in terms of these shaded or dotted line for that regards. Okay, I'm going to take it away. Don't need it because I don't want it being interpreted as a vertical asymptote. Now, since we're to the right of this point, we don't have a y-intercept.
No.
And there are a couple of ways you could do this. Here's the way I used to do it. I would draw the function all the way to the y-axis because I know how to graph that, right? That's 2x.
Yeah.
And then I would erase this part right here.
Okay.
Okay, and then this is a closed dot right there. Well, that's a hard way to do it and not the correct way to do it. Correct way to do it is let's find out where it is at this point.
Okay.
So when x is 1, where is our function?
So if x is 1, so would we just plug it into the equation?
Yeah.
Okay, so it'd just be 2.
Okay,
For the first
that point is on that line, right?
Yeah.
Now, I'm only going to the right. I'm not going to draw a y-intercept, but the right, I know what the slope is, so I can go up 2 and over 1. So that's what that function looks like.
Okay. So you would start, so I'm kind of confused.
Yeah,
So like you would
start your point by plugging in the 1 into
Oh, so that would be the point. 1, 2.
right. And we're
1,
going
2.
to do the same thing for the second one. Even
Okay.
though it says x is less than 1, so you wouldn't think that, well, you can't plug in 1 to that. But we have to know where it starts.
Okay.
Well, where does it start? When you plug in 1 into the second equation,
yeah. So it would be -1 plus 2, so just be 1.
Okay. So
up 1 over 1.
Open circle.
Yeah.
And,
because there's no equal sign under it.
right. And how do I draw the rest of that?
And then you would do down 1 over 2.
Well, we're doing the second function. What's the slope of this?
So the slope would be -1 over 1. Or 1 over 1.
1
over 1.
minus 1.
Yeah.
-1 for sure is the slope. And
okay.
That's how you do it.
Okay. That makes sense.
In other words, we didn't use the y. I could have used the y-intercept of 2.
Yeah.
Because I am going through the y-axis on this part of it. But you want to use the same methodology for all of these problems, where you plug in this number into that function, and that's where you start, and then you use the slope to draw the rest of it.
Okay.
Okay? So
cool.
Erase this part, and we'll next one.
Cool.
I'll leave my grid up there in case it matters. So what point on the number line am I interested for number 5?
-2.
Let's do to the right first. And this is something else you may want to reverse. If you feel comfortable going left to right, then I'm always going to plot this bottom one first. In fact, let's do that for here.
Okay.
The thing is, I've been telling people for years to always start in the upper right. So, but it doesn't really matter whether you start in the upper right or the lower right. If I'm starting in the lower right, then I'm going to be graphing this part of the function first.
Okay.
Let's do that. It's a little bit better to think from left to right. So on number 5, where's my starting point?
And we're talking about the second equation right now.
Correct.
Okay. So it'd be -2 -2, so -4.
Okay. Is it open or closed?
And that one would be close or open. My bad.
And how do I draw everything to the left of that? Let me take this point off. That's not a key point here.
Okay. Oh, so like you would start the open point at -4.
That's what I did. Yeah.
Is that okay?
And it's a straight line. These are all linear functions. There's no quadratics yet. Okay.
Okay.
So straight lines, the only thing we need is slope. What's the slope of this function?
And then the slope would be up 4 over 1.
The second function. What's the slope of that? That's
so we got
x minus 2. What's the slope of that?
X minus 2, so down 2 over 1.
I say y equals x minus 2. What's the y-intercept?
-2. And then up 1 over 1.
The slope is 1.
Just 1, yeah.
Well, we can figure out how to make that slope, but the slope is 1. It's very important that you know exactly what the slope is and when you look at these. Okay?
Okay.
So the slope of this function, the second function, is 1. Now, how do I draw that?
Is 1. So you're just, when you just go up 1 over 1.
Well, if I go up 1 and over 1, I'm in that territory that I'm not supposed to be in. Remember, I'm going to the left. So I got to get a positive 1, I got to go down 1 and over 1.
Okay.
It's the only way I can get a positive slope. I can't go up 1 and over 1 and put a dot there because that's not my part of my domain.
No.
My domain is only to the left of -2.
Okay.
Okay, so now let's do to the right. In other words, let's finish. So what's the point that we're starting in?
So for that one, it would be -1.
Correct.
Okay.
So that's right there, closed or open?
And then that would be closed.
And that -1 is right there. And what's the slope of this line?
Esmond step. So the slope of that line would be, hold on. Yes, it'd be a closed dot. And then, so that one was down over. So I'm just still kind of like confused on like how to find.
The slope?
Yeah.
Equal mx plus b, right?
So it would be y equals 2x plus 3.
Yeah. So the slope is always m. So the
Yeah,
slope is
so that
always
one
the
would be,
coefficient of the x. It's that simple.
okay.
It was 2 there, it was -1 here, it was 2 there, and it was 1 there.
Okay, so this one would be up 2 over 1.
Okay, now this time I can go up 2 and over 1.
Yeah, because the x is greater than, right?
Well, our domain is headed in that direction. So
yeah.
it's something like that. Okay. And piecewise functions are almost by definition not continuous functions. You always have to pick up your pencil to draw it.
Right.
It have to be that way. In other words, this one could have come off from there, and it would be a closed dot, you know, if it was a different function.
Okay.
Okay, let's see. We only have 12 minutes.
Okay.
I think we ought to do some of these at the bottom, going the other way.
I agree.
Okay, let's do this one. Notice number 10 is continuous.
It is, yeah.
But it's still piecewise because it's two different linear functions. You can see the slope is different on this one and the slope is different on this one. So
okay.
What we're going to do, our f of x is going to be equal to, and let's start in the upper right.
Okay.
We have 2 points here. What's the key point in this? What's the breaking point where they change?
0, 0.
Okay, so we could say x is greater than 0 up here, and down here we're going to say x is less than, and we can even put in both. We can make that greater than or equal to 0 and less than or equal to 0 because it's clear from the picture that at 0 they're the same.
Right.
Okay, so what is the function? I don't want to confuse you. Let's start from the bottom. What's the bottom function? Looking at the graph, what's the y-intercept?
Down 2 over 1. Oh. So the y-intercept would be, they're all actually down 1 over 1.
Hold on. We're looking at just this portion to the left of the y-axis.
Okay.
What's its slope?
So that slope would be, for the bottom one, it would just be down 1 over 1, minus 1.
What's its slope? Is that a negative slope? Does it look like a negative slope?
It looks like actually a positive, so
well,
it'd be
that's how you
1.
figure it out. You look at it, and you know that the slope's got to be positive 1. So what is that function?
So it's positive 1. So it would be minus, or 1 is less than x, which is less than.
Okay, here's what you're starting with.
Okay.
We want to put it in this format.
Yeah.
What's B?
B would be the y-intercept.
Which is?
0.
Okay. Get rid of that. What's the slope?
And then the slope would be up 1 over 1, so just
That's not a
1x.
slope, Dylan. That's the way to draw the slope. The slope is a single number.
Just 1 then.
1. So there's your equation. Or we don't need the 1, so there's the equation.
Okay.
In other words, you're always trying to put these into y equals mx plus b format. Notice that that's the way everyone is. They're all functions that are y equal mx plus b, except 7, which is just a bunch of vertical lines.
Yeah.
Or rather, excuse me, horizontal lines. 7 is 4 horizontal lines. It's at -4 between those 2 points. It's at -1 between those 2, and so forth and so on. Okay, back to our number 10, because I want to do a couple of these before we run out of time. So now we need the bottom. Okay, first of all, I screwed up already. We were starting on the bottom.
Oh, okay.
See, I'm so used to starting at the top, it's hard for me to make the adjustment. Only today do I realize that most people are going to want to work left to right. So the top one, if I try to put it into this, what is B?
So the top one would be just y is equal to 1x.
What's the slope on the top
one? 1.
Is it?
Yeah.
Well, first of all, you got to go up 2 and over 1. What slope is that?
So up 2 over 1. So the slope would be 2.
Okay. And we know it can't be 1. If the slope was 1, that would be a continuous straight line.
Yeah.
Figured out that that slope is 1. Well, if this slope is 1, it would have to be parallel to that. So we know it's not 1.
No, it has to be 2 over 1.
So what's the function equal to?
So if it's 2, so it'd be x is greater than or equal to...
Yeah. What is this function right here that describes that line?
Which one are you pointing to?
The top one?
Okay, so...
Going to the right of the y-axis?
The one that's going to the... Okay.
It's got a slope of 2. It's got a y-intercept of 0.
Yeah, so it'd be x is greater than or equal to...
No, we've already got that part. What's the function right there that goes there?
Oh, that's what, okay. So the function I'll get there would be 0.
2x. Remember,
so you would just put the x value, like, or the slope there?
Now hold on.
Okay.
What we're trying to do is write an equation of that line.
Okay.
Okay? Well, an equation of that line is in the format mx plus b. So once you know what b is, and once you know what slope is, it's simple. Y equal to x. As soon as we discover that the slope is 2, that's the function. Okay?
Okay.
So if you can write an equation of one line, just that part of it on the right, then you can do both of these. Piecewise is just a combination of functions. That's all it is, depending on domains. Now, let's look at the next one. Hopefully we can get this one covered.
Yeah.
How many key points are there? In other words, when I start my x, you know what? Let's start at the top and the left. Because there's nothing that says you got to do it in the order that they're doing it here.
No.
What's my key point? 11 to start with.
Yeah, so the key point would be 2. Or, no, 1. My bad. Yeah, it'd be 1.
-1.
Oh, we're starting on the left.
We're starting on the left and the top. So, in other words, x is less than or equal to -1 is that this line here is the line I'm going to write first.
Okay.
Okay, what's the equation of that line?
So the equation of that line would be y is equal to 1x minus 1.
Almost, but not quite, because if I were to extend that line, I would have a y-intercept. What would it be?
It'd be 2.
So the equation of that line is x plus 2.
Just x plus 2. Okay.
And it's less than or equal because it's a closed dot at that point right there.
Okay.
Okay? Now, I didn't have to extend that line to the y-intercept to figure out what the equation was.
Yeah.
And that's not a particularly good way to do it anyway because it's not exact enough. Okay? So how else can I figure out what this thing is? Well, I know that it's y equal mx plus b, and I know the slope is 1. So if I want b, let's plug in a known point. Well, what's that point right there where the black dot is?
That point would be -1, comma 1.
Right. So if I plug in the y value of 1, the x value of -1, I solve for b. B now equals 2. And so now I have my equation. It's got to be x plus 2. And you didn't have to do it by extending that and see where it crosses the y-axis. A little trickier, but still not that tricky.
Yeah.
Now, what is the next 2 points that are key? In other words, when x is less than what and greater than?
So it'd be x is less than 1, and then
Correct.
Which is greater than or equal to 2.
Hold on.
Or less than.
This interval that you're looking at that has the middle line on number 7, that interval goes from what to what on the x-axis?
So the one on the far right?
No, we're in the one in the middle.
Okay.
What's the domain of that middle part piecewise function?
0, 3.
No, the domain. What are its allowable x values? Anything from -1 to +1, right?
Yeah, my bad.
So that's how you write that.
Okay, that makes sense.
X is between -1 and 1. That's how you write that in the domain. Now, what's the equation of this? And this one's easier because it does cross the y-axis. So we know what b is, and it's easy enough to figure out slope. What's the equation of that middle line?
Y is equal to 1x plus 3.
Is it 3? Count it. It is 3. I was thinking 4. Thank you.
Oh, you're good. Cool.
And finally, the line on the right is when is greater than or equal to what?
To 1.
Okay. And what's the equation of that line?
Greater than or equal to 1. And then the equation would be y is equal to 1x plus 2.
What's the y-intercept? Doesn't it?
Wouldn't it be 2?
No, it's at 2 when x is 1. So let's figure out what it would be. In other words, here's what we have.
Oh, so it'd be 1, like if you continued the line down.
Right, you could do that, but again, let's do it this way. To solve for b, we've solved for the slope. We know the slope is 1. So now let's substitute a point that's on that line. Any point would do. but the point that is most significant there is 1, comma 2.
Yeah.
All right. So I'm going to plug in 2 for y.
And then 1 for
x. And that's not 1 for x because the slope is 1. That's 1 for x, okay?
Okay, yeah.
And now solve for b, you get 1.
Is 1.
So the equation of this line is x plus 1.
Okay.
And that's exactly how you do all of these. Now,
okay.
before you go, let me just tell you what kind of function. This is the greatest interval function. Greatest integer function. In other words, this function like this is how you write that function.
Okay.
But it's between, I'm sorry. That's not the way they want you to do it.
It's okay.
They want you to give the equation of a horizontal line. Remember up here on 7 when I said all this is 4 horizontal lines? No, that's what this is. It's 1, 2, 3, 4 horizontal lines. So we have a horizontal line going from -5 to -3. That would be y equals -3. And then we have a horizontal line, the domain, when x goes from greater than -3, but greater than or equal to -3 and less than -1, the equation of the line is y equal -1.
Okay.
And so forth and so on. In other words, instead of treating this like the greatest integer function that it is, it has 4 piecewise functions. I forgot for a moment what section we were working on. So.
No problem. Okay.
All right.
Cool.
I'm sorry we didn't have a little more time because I would have liked to go on over a few more of these. You don't seem that comfortable with these yet. But
yeah, we could. Yeah.
Always keep that in mind. Even though they're not always going to be linear, you could have an x squared. In other words, if I could have something that looks like this, I could have a straight line up to there, and then I could have a parabola from there to there.
Right.
Whereas to the left, the equation would be y equal x, and to the right, the equation is y equal x squared. So that when x is less than 0, it's y equal x. When x is greater than or equal to 0, it's x squared. And that's how you do them. So they're not all linear, but everything on this page is linear. Okay. Is anyone, before you do go, is there anyone on here that you know is going to give you trouble that we could look at right now? Even 13 looks hard, but
it's actually not.
3 straight lines, right?
Yeah, exactly.
So you set up your domain between that point, and you figure out the equation of that line. Horizontal lines are always y equals that number, which is 2.
Yep.
And then this thing, figure out its slope and what b would be, and go from there. Number 8 is not hard, even though that's the -2/3. So what? Slopes can be negative. These are all horizontal lines also. You just have to know which one to put where. Start with the domain.
Yeah.
Now, see, I notice here they're going from left to right and top to bottom.
Yeah.
These first problems went from right to left and top to bottom. And I don't like that. I like going, notice number 9 goes from left to right and top to bottom. Starts out 0 to 1 and then goes from 1 to 2 and then goes from 2 to 3. I don't know why they don't. And number 6 goes top to bottom, left to right. So they threw me a little bit of a curve with number 4 in talking about it. That's the only difference it makes. It really doesn't matter whether you're going top to bottom, left to right, or top to bottom, right to left, as long as you know which interval you're in.
Yeah, exactly.
That's the key.
Okay. Cool.
All right.
That makes sense.
Dylan, I will let you go.
Okay,
You guys
sounds good. I would
are off
have.
school tomorrow, right?
We are, yeah. I would have extended the today, but we have to leave in like 10 minutes for
That's fine.
baseball. So.
No, not, well, good luck. You got a game today, huh?
We do. We have a couple. Yeah, we play. I
Cool.
don't know who we play honestly, but
I
yeah,
should
we
have
had a
figured
couple
that, I
yesterday.
should have figured that out when I saw the 9:30 session.
Yeah,
Because that
yeah.
surprised me a little bit. I'm not used to getting 9:30 Sunday morning sessions from you. But I
Right. Yeah.
should have figured there was a baseball game today. Well, good luck.
Well, thank you. I appreciate it. Yeah, we're first in this tournament so far, so
Great.
gonna
Right.
keep it like that. Yeah.
All right. Well,
All
I'll
right.
talk to you next time.
All right. Sounds good. Thank you, Mr. Cowan.
All right.